In this video, we're going to continue our work with stationary points and look at some more challenging questions. This is question 7. In part A, we need to find the maximum value of a function f of x is equal to the quantity 1 minus 2x multiplied by the quantity 3x squared minus 5, where x is equal to or greater than 0, giving our answer to 3 significant figures. Okay, let's just look at this function right here. This is f of x. If we expand this out, we're going to get a cubic equation, and it's going to be negative. We're told on here that it's only defined for values of x equal to or greater than 0. If I drew part of this curve, what we would have is the cubic, and it would look something like so. So it's negative, and it would come round, it would do something like this, come back round, up, do something like that, and then now turn round and something like so. So this is a rough sketch. Remember, this is only defined for values of x equal to or greater than 0. So all we've got now is this side right here is not going to exist. So let's just, if I just put that part on there, that now is not going to be that. It's just these values here. So if we look at this particular point right here, what we can see, this is going to be a maximum point. So this is a max point. We're only going to have one stationary point on this cubic equation if we're looking at it for values of x equal to or greater than 0. I can see that from the way the curve is going to be. So if we can find the y-coordinate of this maximum point, then we have the maximum value of a function, which is going to be just here. So that will give us the maximum value. So the maximum value. We can do this by differentiating the function, setting it to 0, solving for the x-coordinate, and substituting back in to find the y-coordinate. So let's take our function right here. We've got a product. If you've learnt the product rule, you can use that. As we don't in this particular unit, all I'm going to do is expand the brackets, differentiate, and set to 0. So multiplying through, we're going to have now 3x squared. Then we're going to have now minus 5. We're going to have now negative, so that's going to be negative 6x cubed, and then we're going to have now plus 10x. We can say now f dashed of x is equal to 0 for now the stationary point, which in this particular case will be a max. So we can say that f dashed of x, just differentiating the function, negative 18x squared plus 6x plus 10. So setting this equal to 0, 0 is going to be equal to negative 18x squared plus 6x plus 10. I'm not even going to try, I'm just looking ahead, I'm not even going to try and factor out. I'm simply going to put this through the quadratic equation with a being equal to negative 18, b being equal to positive 6, and c being equal to positive 10. Again, if you wanted to, you could go ahead and simplify this. I'm not going to bother. It's going straight through the calculator. So in my calculator now, let's go ahead and look at that. Now we're going to get two values to this. One of them will correspond to this minimum point just here. So it'll be the x-coordinate of the minimum. We want now the value that's going to be greater than 0. So what we'll have then is now negative 6 plus or minus the square root of now 6 squared, which is going to be 36, minus 4 times by a, which is a negative 18, multiplied by the c, which is going to be the 10, and we put all of that over 2 lots of a, which is going to be negative 36. So we can see on here that x is going to be equal to, so x is going to be equal to 1 plus or minus root 21 over 6. We can say that x is equal to or greater than 0, therefore we've got now on here, and if we just look at this now, we've got 1 minus root 21 over 6. So we're going to need now to change this over for the positive. So 1 plus root 21 over 6 is going to give us this value right here. Therefore, x is equal to 1 plus root 21 over 6. Now 4, and just writing this in, 4 now the stationary point. So what I'm going to do is the following. I'm going to do f of 1 plus the root 21 over 6, and that now will give me the value of the y-coordinate just here, and hence the maximum value of the function. That's the largest the function can be. So if I just store this in, I'm going to store it in as a. You don't have to, you can just have it as your answer. So what I'll have is 1 minus 2 lots of the answer, multiplied now by 3 lots of the answer squared, minus 5. Or I could have done A instead of answer for those. So that's what we get, and we can say now that that is going to be 2.0685, so 2.0685, so 2.0685 ... So that's going to be 2.07 to 3 significant figures, so to 3 SF. So that is the maximum value, and that's what we've done. Okay, so that's all done. Okay, in part B, we need to prove that the answer found in part A is a maximum value by evaluating f double dash of x. So what we need to show is that this is a maximum point. So what I can say for max point, as we've learnt before, for max point, we can say f double dash of x, the second derivative, when we evaluate it with the x-coordinate of a stationary point, will be negative or less than 0. So if we get an expression for f double dash of x, well, f double dash of x is simply going to be the derivative of this, which is negative 36x plus 6. So if we do f double dash of our 1 plus root 21 over 6, that, and I'm just going to substitute this into the calculator. So remember, I've stored this as a, so negative 36a plus 6, that's going to give us negative 6 root 21. So negative 6 root 21. Therefore, we can say max point, so max point and max value. So max value at x is equal to 1 plus root 21 over 6. So all we've done is simply show that it's a maximum. Okay, in part C, we're asked, is the function increasing or decreasing at x is equal to 3? If we look at this right here, what I'm going to do, if I just grab this up, let's say that x is equal to 3 is somewhere around here. It's not ideal, this is not brilliant. We can see quite clearly that this is going to be a decreasing function. So if you wanted to justify graphically drawing a tangent, you could do. Alternatively, if you wanted to play safe, we can say now for increasing, so for increasing functions, so for increasing, we can say f dash of x is greater than 0. For decreasing, so for decreasing, we can say now that f dash of x is less than 0. So greater than 0 for an increasing function. All that's saying is if we evaluate the gradient where it is the x-coordinate is 3, then we'll be able to see whether it's an increasing or decreasing function. That is, the tangent to the curve at that point is either going to have a positive or a negative value. So if we do f dashed of 3, so all I'm going to do is simply substitute in 3 into here. So if we just substitute in 3, so what we'll have, not into this one, where did I put it? Just here, that's what we want. So what we're going to have then is negative, let's just do that. So negative 18 times 3 squared, which is times by 9. Then we're going to have plus 18. So plus 18 plus 10, what's that? Negative 134. So negative 134. So all I've done is simply gone ahead and substituted it into f dash of x. Therefore, we can say now that this, as expected, is a decreasing function as it's now less than 0. So if you wanted to simply say graphically, we can see, but you're not asked to draw the graph, hence why I didn't use that particular method. So there we go. Don't expect them just to be stationary points. We might have is it an increasing or decreasing function. Okay, this is question 8. In part A, we're asked to sketch a curve of y is equal to x cubed minus 6x squared plus 5x plus 12 showing any points of intersection with the coordinate axis. So this initially isn't anything to do with differentiation. It's a cubic equation that has now a constant. So what we need to do is use the factor theorem. We've looked at curve sketching in a previous unit, so hopefully you're okay with this. Okay, so let's first think about this curve. We can say now when x is equal to 0, we can substitute that in, y is going to be equal to 12. So from that, we've got now the y-intercept. So all I've done is subbed in x is equal to 0. What we're now going to do is find where this crosses the x-axis, and that's when y is equal to 0. So when y is equal to 0, I need to go ahead and look at factoring this. The way in which we do it is consider the constant, and we do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So what I'm looking to do is find a factor of 12 that will set this equal to 0 when we evaluate it. If that's the case, we can use that as a factor as we've seen before. So if we just define f of x is equal to x cubed minus 6x squared plus 5x plus 12. Now, if I substitute in, let's say, 1, that is not going to give me 0. Let's try f of negative 1. F of negative 1 will be negative 1, we'll subtract 6, we'll subtract 5, and we'll add 12. That looks good. That's going to be equal to 0. Therefore, we can say that x plus 1 is a factor. So is a factor. If you haven't seen that method before, please do check it out. I'm assuming that you're fairly comfortable with this. What I'm now going to do is use polynomial long division and set this up. Again, if you haven't seen this, please check it out, as I'm kind of half expecting you should be cool with it. Right, x plus 1 into now x cubed minus 6x squared plus 5x plus 12. You could, of course, searched for more factors and set this as a product of 3 linear factors, or a linear factor and a quadratic. I'm just going to use polynomial long division. So x cubed over x is x squared. We multiply down x cubed plus now x squared. Subtracting away 0 minus 7x squared, and we bring the 5x down. X is into negative 7x squared will be negative 7x times, so negative 7x squared minus 7x. Subtracting down 0 plus 12x and bringing down the 12. This is looking good. X is into 12x, that'll be plus 12, so we'll have plus 12x plus 12. Subtracting down, what we're going to have is now 0 plus 0. Therefore, what we can do is write now f of x is equal to, now the linear factor of x plus 1 multiplied by the quadratic factor of x squared minus 7x plus 12. This will factor right here, as we've seen before. What we're going to have, x minus 3 and then x minus 4. So all I'm going to do is sketch this up. We've now got our 0 value, so let's go ahead and do this. Let's just draw that. So what we can say now up here, we've got from our factors negative 1, so x is equal to negative 1, we've got 3 and we've got 4. This is a positive cubic equation, so what I'm going to do on here is put now the negative 1 here, so that's negative 1, 0. We're going to have 3, 0 just here, and we're going to have 4, 0 just here. It crosses the y-axis now at 0, negative 12, so let's go and put that on. And this isn't, the xy scale is not the same, but I'll just put that on anyway. So what we've got then is the following. We've got these values on here, and we've got now a positive, so this is going to be now a positive cubic equation, which we need to go ahead and locate. Let's just put that in the correct place. I don't know why I've put it there. Let's put 0, 12 rather than 0, negative 12. So that needs to go. Right, positive cubic then. So we're starting here in the third quadrant. We'll come up, we'll come round through this point right here. We'll turn round, back down like so. We'll come through here. We'll turn round, and then we'll be back like that. So that now is a rough sketch. Got all the information on. Do check. I don't know why I put negative 12, positive 12 quite clearly, and that's what we've done. Okay. We're asked to find the x-coordinates of the stationary points given our answer as exact fractions. So what we're going to have then, if we look at this here, let's just put this on. We're going to have a stationary point somewhere just here and a stationary point somewhere just here. That is where the gradient is going to be 0. So just there, somewhere around there, if I drew a tangent, we would have now a line parallel to the x-axis. So all we're asked to do is find the x-coordinates. We're not asked to find both coordinates, we're just asked to find the x-coordinates. So what I'm going to write then is for SP, so for SP, we've got f dashed of x is going to be equal to 0. So if we look at this now, we've got f of x is just here. So, or we can write, in fact, we're using y, so f dash of x is equal to 0, or dy dx is equal to 0. So if y is equal to x cubed, so we've got x cubed, then we've got now minus 6x squared plus 5x, so minus 6x squared plus 5x plus the 12. Dy dx, the gradient function, is going to be 3x squared minus 12x plus 5. So here we're giving our values for the x-coordinate as exact fractions. That means that I'm just going to simply use the quadratic equation again. So 0 is equal to 3x squared minus 12x plus 5. We can see the value of a is 3, the value of b is going to be negative 12, value of c is going to be positive 5. So let's put this now into the calculator. So we'll have now negative b, so minus 12, so that'll be 12, plus the square root of negative 12, which is negative 12 squared, which is 144, minus 4 lots of a, so that's going to be 4 lots of 3, multiplied by c, which is going to be 5, all over 2 lots of a, which is going to give me now 6. So what's that? 6. So what we've got then is 6 plus root 21 over c. So x is going to be equal to 6 plus or minus root 21 over 3. So let's just have a look at that. So that one is 3.52, which we would kind of expect looking at the graph, 3.52. So if I just put it here, this one right here is going to be x is equal to now 6 plus root 21 over 3. And this one right here, let's put that one on, this is going to be 6 minus root 21 over 3. And that now gives us the x-coordinate of the stationary points. So if we just look at that now, let's just put in the negative here just to have a look. And that is going to give us 0.47 and so on and so forth. And that looks okay relative to my graph. Again, not massively accurate. Okay, using the graph, determine the nature of the stationary points. So quite clearly from this, we can see that this one right here is going to be a max. We can see that. We've got now positive, positive, positive 0, and then we've got negative, negative, negative. And then this one right here is going to be a minimum. We can see that. We've got negative, 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 0, and then we've got positive, positive, positive. So we were doing this graphically. We weren't finding the second derivative. It just says using the graph determine the nature. Right, it's a maximum, and that is a minimum. In part D, it says on the same set of axes, draw a different cubic equation that only has one stationary point. Write a possible equation for the curve. So if we've got one stationary point, what we could do here is simply go ahead now and draw y is equal to x cubed. That's the easiest one. So what we'll do, we'll come through, and this is our point of inflection. So we'll end up with something looking like so. So y is equal to x cubed, and I'm just going to write now that that is going to be the SP, and it's a point of inflection. So point of inflection, as we've learned before. That's the easiest thing to do. So that is at the origin. So all it's asking us to do is simply now show that we understand that we can draw a cubic equation with now one stationary point, and that stationary point in this particular case is going to be now a point of inflection. So nice and logical, nice and straightforward. Right, let's have a look at another question. In question 9, we're given g of x is equal to 1 over x plus 16x, where x cannot be equal to 0. We need to show that the distance between the two stationary points on the curve y equals g of x is 5 root 41 over 2 units. So this is g of x. G of x, we could have had f of x, they're just functions of x. So all I'm going to do is write here for SP, so for SP, g dashed of x will be equal to 0. So let's go ahead and use this. So what I'm going to write is g of x is going to be equal to 1 over x is x to the negative 1 plus 16x. So g dashed of x is going to be negative x to the negative 2 plus 16. So 0 is going to be equal to, and I just write this as now negative 1 over x squared plus 16. Rearranging and solving for x, 1 over x squared is equal to 16. 1 over 16 is equal now to x squared. So x is going to be equal to plus or minus now 1 over the square root of 16, which is going to give us 1 over 4. Okay, so let's now look at x. So when x is equal to 1 over 4, all I'm going to do now is substitute this in to find the y coordinate. So if I put in 1 over 4, that's going to be 1 over 1 over 4, which is 4, plus now 1 over 1 over 4, and then we're going to have on here, what's that going to give me? 8. 8 in total. Y is going to be 8. So I've simply substituted that in, and we'll get 1/4, comma 8. When x is equal to negative 1/4, what we'll have now is y will be equal to, and if I just substitute that in, I'm going to get exactly the same value. It's just going to be the negative, so that will be negative 8. So what we'll have is now negative 1/4, comma negative 8. So we want to show the distance. So we can say that the distance, just writing this down, the distance will be equal to the square root now, and we're just simply using Pythagoras. We'll do 1/4, subtract now negative 1/4, which we need to square, not raised to the power of 8, square, plus now 8, subtract negative 8, which we need to square. So let's, as this is a show that question, I'm just going to be a bit more careful. So what we'll have then is the following. So what's that going to be? 1/4 plus 1/4 is 1/2. 1/2 squared is 1/4. What's that going to give me? 8 subtract now, that's going to give me 16. 16 squared is 256. So let's go ahead and put this in a calculator. So the square root of 0.25 plus the 256, that's going to give me now 5 root 41 over 2. So that's as required. So 5 root 41 over 2 as required. So all I've done is simply found now the stationary points by setting the derivative equal to 0, finding the x and y coordinates, and then going ahead and plugging them into the distance formula and going from there. X can't be equal to 0 in this one quite clearly because we can't have division by 0, it's undefined. But that's a nice question. All we're doing is looking at those stationary points. If you wanted to look at this graphically, we could do that. Let's put this in. So y is equal to 1 over x. Let's put in x, 1 over x. There we go. Plus 16x. And let's just scroll in. Okay, so this is what we've got. So we can see this point right here is 1/4, comma 8. That point here is negative 1/4, comma negative 8. So this now is our maximum, this is our minimum point, and all we've done is gone ahead and used Pythagoras to go and solve for the distance between the 2 points. So there we go, some more challenging questions on stationary points that have included other topics.